My topic today is revenge. I think that's the core of the semantic paradoxes, and I'm going to focus on non-classical approaches to the paradoxes and revenge, as I think it arises for this family of solutions. It's going to be a bit of a weird talk. So part of it is a published paper in the Australasian Journal of Philosophy called Generalised Revenge. And then we received some, so this is joint work with Murzi Rossi, with whom I'm writing a book for Oxford University Press. And so we are writing the chapter on non-classical approaches. So we are presenting some work in progress here. And so we got some responses from Luca Rosenblatt, and then there's a response that's been worked on by Julian Schlöder and Luca Incurvati. So, and in the course of work preparing this talk, there's been this enormous correspondence that's been going on for weeks now, and with the dialectic that's been unfolding. And I cannot say too much about this because partly it's their work in progress, but I want to say something about it, and it's still ongoing. And that's where the meat of the talk is. And so I'm going to go quickly through the sort of to the preliminary, the published stuff, and also the stuff on Rosenblatt, where I think it's pretty clear what Lorenzo and I should say. I'm going to try to get to the bits that are interesting for me, trying not to say too much, but to say enough to make it understandable. Okay, so yeah, that was the introduction. Right, so semantic paradox, I think that's a serious problem. We get triviality from very basic ingredients that we find essentially in arithmetic. Names, the possibility of naming sentences, some way of simulating self-reference, classical logic, actually minimal logic maybe, and then the naive truth principles such as the truth introduction and truth elimination. I think we are all familiar with this. And once we have this, we can prove that I am the Pope, which I'm not. So that's a serious problem. There's many possible ways out. I think there's two main ones that are worth considering. Either restrict the naive semantic principles, so restrict the possibility to move from phi to phi is true and back in some way, and keep classical logic, or restrict classical logic. So I'm going to focus on the second option. In the book, Lorenzo and I defend a classical approach, a contextualist approach that preserves actually the interderivability of phi and phi is true. It's just that when you do this, sometimes context may shift. You don't see it, but in the background, there's a context shift, and that's how you preserve consistency. But that's not what I want to talk about today. Right, revenge. So there's various families of non-classical approaches. I mean, these have been blossoming really since Kripke's landmark paper in 1975, Outline of a Theory of Truth. So you can either go the Kripke non-classical way and invalidate the excluded middle. If you do this, you invalidate negation introduction and error introduction. Or you can go the bi-consistent way, and you invalidate the elimination rules for the non-positive logical operators. So for negation and for the error, and you accept that certain sentences are both true and false. For instance, the paradoxical sentences. Then another option has been discussed more and more is to restrict the rule of assumption, so the axiom of reflexivity. Might seem crazy, but that is an option. I mean, all these options are variously unintuitive at some level. I mean, anything you do to deal with the liar is unintuitive at some level because the ingredients are extremely compelling and extremely basic. So we shouldn't balk. We shouldn't say, oh, that's crazy to restrict reflexivity. All the options are on the table. Another option, actually, Lionel is in the audience, and that's the option that Lionel also has sympathy for, and that's the non-contractive option. So there's various ways of restricting the rule of contraction. And this is going to invalidate the subproof of for negation introduction or conditional proof of the paradox is going to block the paradoxes. Another option that's been discussed recently is to invalidate cut. So these are different ways. I mean, these are the basic logical ingredients of the paradoxes, and you can invalidate any of them. And these are the options, the resulting options. There's another option on the table that I think is extremely interesting, and that's the option that Julian and Luca are developing in a book in progress, in a paper that's under review. And they have a really impressive framework where you have rules for assertion, for rejection, and for weak rejection. And in this framework, they give a unified approach to epistemic models. They find a way to be expressivist about morality, about the moral vocabulary. And they do a lot more, and they extend the framework to the semantic paradoxes. And it's interesting because they do things, I mean, for someone who works in the paradoxes, they do something new. And that there's a lot of promise. And the key idea here is that certain rules are valid, so can be valid. So by validity, they mean that they preserve commitment, and yet they may fail to preserve evidence. And they very clearly show that if you have weakly rejected premises, if you have the possibility to weakly reject premises, you have to restrict the subproofs of classical meta-inferences. Otherwise, these inferences are gonna allow you to assert things for which you don't have evidence. So the subproofs don't preserve evidence in presence of weakly rejected premises. So they restrict the subproofs of classical meta-inferences, and they say, well, this loss of evidence preservation can be, the result can be determined by weakly rejected premises that we make use of in our subproofs, and also by the use of semantic rules. So they think that when we apply semantic rules to paradoxical sentences under assumptions, our subproofs are no longer evidence preserving. And that's, of course, the question is, what is our reason for thinking that these semantic rules don't preserve evidence? We're going to return to that later. I'm going to say something about this. I'm not going to say, I mean, we've exchanged maybe 80 emails, so I'm not going to go through all of it. And a lot of things are irrelevant, but I think was been a very interesting correspondence. Right. I mean, there's a lot to like about non-classical approaches. One thing is that they validate the naive semantic principles, at least the ones about truth. They can recapture classical logic when it matters. So they come equipped with classical recapturing principles. We're going to see some examples, such that a sentence satisfies those principles in the relevant non-classical theory, if and only if it satisfies all the principles of classical logic. So you can recapture physics, arithmetic, and all the classical theories you want to keep. And you try to, I mean, the theory is going to be non-classical only when classicality creates trouble. And then, of course, you don't want to block the paradoxes without giving a reason why you want to block them at a certain place rather than another. So you try to offer, as a non-classical theorist, a diagnosis of what goes wrong in the paradoxes. So we are all familiar, I think, with paracomplete approaches, which restrict the excluded middle. The idea here is that certain sentences are in some sense indeterminate. And for this reason, they cannot satisfy the law of excluded middle. So we give a diagnosis of what goes wrong in the paradoxes. So there's notions such as indeterminacy, instability for some non-contractive approaches, and so far and so forth. Then, of course, Lorenzo and I claim that there's an unavoidable revenge problem that arises. And the novelty, I mean, this is something that everyone has been saying, that lots of people have been saying for a long time. The novelty of the argument that Lorenzo and I give in the generalized revenge paper is that we find a recipe for producing a uniform recipe for producing revenge arguments for each of the non-classical approaches that we have that I've briefly introduced. I mean, the starting point is that each non-classical theory makes a distinction between two kinds of sentences. I mean, they invalidate, on pain of paradox, certain classical principles. So, for instance, paracomplete approaches have to invalidate the application of negation introduction to the claim that the liar sentence lambda is true. So in each non-classical theory, there's going to be some sentences that don't satisfy all the principles of classical logic, as a matter of fact. So if you think of the semantics, the ones that receive non-classical value are not going to satisfy all the principles of classical logic, for instance. So lambda. At the same time, you have sentences such as 0 equals 0 that do satisfy all the principles of classical logic. So there's the sentences of two kinds. So we call paradoxical, unparadoxical in S, the sentences that classify all the classical principles in a given theory S, and paradoxical in S, the sentences that classify all classical principles in S only on pain of triviality. And the idea here is that in each non-classical theory, there's going to be some classical recapturing principles pi 1 to pi n, such that a sentence satisfies them if and only if it satisfies all the principles of classical logic. So, for instance, in the case of paracomplete theories that are familiar, I assume these principles pi 1 to pi n are just the excluded middle, phi or not phi, and so a sentence satisfies in these theories the excluded middle if and only if it satisfies all the principles of classical logic, so if and only if it behaves fully classically. And this justifies intuitively the following very naive, as a classical logician, is extremely naive, rules for paradoxicality. So you have a paradoxicality introduction rule such that, if you can derive absurdity from phi and not phi, this means that phi is paradoxical, because that's the notion of paradoxicality that we have introduced. A sentence is paradoxical in S if and only if it satisfies all the principles of classical logic only on pain of triviality. And we know that phi and not phi is a classical recapturing principle in paracomplete theories. So a sentence satisfies the excluded middle if and only if it satisfies all the principles of classical logic. And then you have the corresponding harmonious elimination rule. So if you assert that phi is paradoxical and that it satisfies the excluded middle, so you assert phi not phi, then you get a contradiction. I mean, these claims are bound to entail a contradiction, because paradoxical just means if it satisfies the excluded middle, then absurdity. Right, so now we claim, so it's a theorem that if you close a paracomplete theory under these rules, paracomplete theory of truth with the truth rules that we have seen at the beginning, the theory explodes. I need to briefly go through the proof, because Rosenblatt's criticism presupposes some knowledge of the proof. We don't need to look at the details, just the basic moving parts. So first, we show that any such theory proves that the liar sentence is paradoxical. So there's a turnstile missing at the end. That's the first typo I noticed. There's going to be many more. So we prove that lambda is paradoxical. We don't really need to go through the proof, but no, I'm getting confused. No, I wanted to say these are nice rules, one might think. Why? Because they allow us to prove things that we know are true. For instance, they allow us to prove that lambda is paradoxical. We reason paradoxically from lambda or not lambda. We derive absurdity from this supposition, and we just apply the introduction rule for the paradoxicality predicate, and we assert, there should be a turnstile here, I'm very sorry, we assert that lambda is paradoxical. And so these are nice rules, one might think, because they allow us to say things that we know are true. But again, like I was saying, these rules are explosive. We show, so we give a liar-like argument. So these are fancy, these revenge arguments are just fancy liars, or they're basically liars. So instead of having a sentence that's lambda that's identical to lambda is not true, we have a sentence rho that's identical to if rho is true, then it is paradoxical. Then we have a lemma that says that if the extruded middle holds, then rho is paradoxical. We're not going to prove this, you just take my word for it. And then we show that if we have this, given this lemma, if we make use of par elimination, which we have here at the second line of the proof, we can apply par introduction, and we show that rho is paradoxical. So, right, we assume this is just natural deduction in sequence style. You should look on the right of the sequence. We have rho is paradoxical. We have that it satisfies the extruded middle, but these two things are incompatible, so we get absurdity on the assumptions that are listed on the left. So on the assumption that rho satisfies the extruded middle, taken twice, we contract, so we get that this assumption that it satisfies the extruded middle yields absurdity, so which is the content of the paradoxicality predicate. So we assert that rho is paradoxical, right? And then we get we get triviality, because we have just proved that rho is paradoxical, but this proof gives us a proof of if rho is true, then it is paradoxical by error introduction with vacuous discharge of rho is true. Well, that's the sentence rho. So by disjunction introduction, we prove the relevant instance of the extruded middle. So we apply parelim and we get absurdity. So that's the argument. The key thing to notice here, that the reason why I presented it is because Lucas Rosenblatt is going to complain here that the use of par elimination is somehow illicit. Actually, Julian and Luca, they say the same thing, but they motivate their claim in a completely different way. Right. So, and then the content of the generalized revenge paper is that the argument we have just given can be replicated for any non-classical theory that satisfies classicality principles. This idea that the sentence phi satisfies in S all the principles of classical logic, if and only if it satisfies certain classical recapturing principles for S. So we run the arguments against consistent approaches, making use of the notion of paradoxicality, and dually we run the argument against inconsistent but not trivial approaches, making use of rules for unparadoxicality. But the details don't really matter. I mean, these are the main things. Okay, so first philosophical important point. There's two kinds of objections by our light that one can run at this point against this kind of argument. And of course, we don't pretend that these arguments show these non-classical approaches to be trivial once and for all. I mean, it's philosophy, and of course, we're using naive rules that we have many reasons to put in doubt. So here's two reasons. So one, that's the reason I find more compelling. One is just to say, well, suppose we interpret the paradoxicality predicate as derivability in S. And we know that these are predicates that can be defined within theories of arithmetic and so on and so forth. Then the rule parelim validates S is reflection principle. So if phi is provable in S, then phi. I don't show this, but the elimination rule for the paradoxicality predicate basically entails this reflection principle. And we know that the theory S cannot be consistently closed under all instances of its reflection principle. So something has gone wrong here. So either the rule is unacceptable or paradoxicality cannot be interpreted as derivability. And that's a strong argument and field in many exchanges. That's one of the things he has said. He has said, look, and he's been saying this about naive validity, where you can run exactly the same kind of argument. And he's right about that. I mean, he says, for me, these rules are just derivability, because it's, your notion of paradoxicality is right to insist, is S is paradoxical if and only if absurdity is entailed from some classical recapturing principle in S, which means it's derivable from such a principle in S, one may argue. And so here you have a classical limitative result about derivability that everyone accepts. So the elimination rule here clearly cannot be accepted. And our go-to response here is to say, well, fine, we accept classical limitative results. We are classical logicians. We like this kind of reply. But if you want to take these results seriously, you might remember that there's classical limitative results that apply to truth as well. I mean, the Tarski's theorem. So if you want to play the classical logician about paradoxicality, then if you want to be coherent, you should also play the exact parallel move with respect to truth. So of course, this is not going to convince everyone, but I think it's a decent reply, because of course there are ways to define consistent truth predicates. So truth predicates for sigma 1 sentences or what have you restricted. This can be done. So one, just like there are ways, and we know how to do this, to define probability in a given system within arithmetic. So it seems like it's there might be a tension here to try to be classical about probability, but not about actually not probability. Classical about paradoxicality, but not about truth. Another kind of objection, which is perfectly coherent as far as I can see, is that, well, the non-classical logicians might say, well, the paracomplete logician might say, I already invalidate negation introduction and error introduction. And the same reasons that lead me to invalidate those rules, they lead me to invalidate the introduction rule for the paradoxicality predicate. So if I have any good reason to invalidate negation introduction and the error introduction, then I also have good reasons to invalidate the introduction rule for the paradoxicality predicate. That's perfectly fine. So this would show also that these approaches, the paracomplete logician, for instance, would give a uniform solution to all the paradoxes, including the revenge paradoxes. You always invalidate the introduction rule of the relevant semantic predicate. One thing one consequence of this, I'll give an example. Of course, there's going to be different instances of these examples in different theories. But one example is that you have these non-transitive theories where you invalidate cut. And you have what creates trouble there is the unparadoxicality predicate. And unparadoxical there essentially means cuttable. If a sentence is unparadoxical, means that you can cut on it. You can perform a cut on it. And the unparadoxicality, and they have to invalidate the elimination rule for the unparadoxicality predicate. So it means that they have to accept for some sentence phi that it is cuttable, that it is unparadoxical. So it means that you can cut on it. You accept this. Then you accept the premises of a cut, but you refuse to perform the cut and to infer the conclusion of the cut. So it looks like cuttable doesn't really mean cuttable in these theories. of course, when we say this to Dave Ripley, he gets very upset with us, extremely upset. And so I'm not going to say it once, and I'm not going to repeat this argument. I like Dave very much. Okay, so let's move on then to the critiques. So Lucas Rosenblatt has written a nice paper in field studies called, has published a nice paper in field studies called Paradoxicality Without Paradox. And he says, well, the paradoxicality, so he likes paracomplete theories, so he only makes his point about paracomplete theories, but presumably they carry over. So, but let's stick to paracomplete approaches for the sake of definiteness and also time. So his idea is that the rules for paradoxicality there make good sense when applied to sentences such as lambda. And we've seen in that slide where I started saying the wrong thing, where we proved that lambda is paradoxical, we put the rules to good use, and there's nothing wrong with that derivation according to Lucas. But he says, well, there's an asymmetry. When you try to prove that rho is paradoxical, and we've seen the slides too quickly, but we've seen the slides at some point, the proof makes use of par-elimination. And he says there's an asymmetry, means that to introduce the paradoxicality predicate, you already need to have a conception of paradoxicality such that it validates the elimination rule for the paradoxicality predicate. And according to Lucas, somehow that's kind of not good. So he says to obtain that rho is paradoxical, one first needs to apply par-elimination to the sequent extruded middle on rho yields that rho is paradoxical, and to reflexivity applies to the rho instance of the extruded middle. Then we contract on the instances of the extruded middle, and yeah, and we get the sequent extruded middle on the rho instance of the extruded middle yields absurdity, and then we can introduce the paradoxicality predicate. So he says, therefore, this example cannot be used to justify par intro for rho, since it already presupposes that the paradoxicality predicate behaves in a certain way. So, and so using the paradoxicality predicate, the elimination rule for the paradoxicality predicate in our proof of that rho is paradoxical is illegitimate, according to Lucas. So we have two things to say here that are not particularly deep. The first is that seems to be a strange way to argue for somebody who typically invalidates non-classical principles when presented with paradoxes. So the non-classical logician typically is not, I mean, at least the one who accepts a transparent truth predicate, so one where phi is fully intersubstitutable in non-opaque context with phi is true, they will accept, they will never invalidate, for instance, the step of truth elimination under the subproof. Whereas this is exactly mutatis mutandis what Lucas is doing here. So that's strange. The second thing is that we can say, well, there is a coherent notion of paradoxicality. It is phi entails absurdity in S if it satisfies the extruded middle. This validates our naive rules for paradoxicality, and we can use these rules to prove that rho is paradoxical. We just don't see why the use of par-elimination in the proof of rho is paradoxical should be a problem. So that's just foot stamping. What perhaps a bit more interestingly, what Lucas ends up doing really is to invalidate par introduction. So we cannot use par introduction there. And so we must be silent about rho. And I mean, I remember talking to Leon Horsten and two others. So these are people who don't say anything about paradoxical sentences. Otherwise, you get into trouble. I mean, you get revenge when you try to, among other things, you try to characterize paradoxical sentences. So, so Lucas says, well, either we are silent about rho, or we introduce a new notion of paradoxicality. But I mean, these options were bad when presented with lambda. we want to say that lambda is defective in some sense. And we want to have just one notion of defectivity. So Lorenzo and I think that being silent about rho is just as bad as being silent about lambda, and that fragmenting the notion of paradoxicality is just as bad from a non-classical perspective as fragmenting the notion of truth. So let's move on then to the interesting part of the talk, failures of evidence preservation. So for Luca and Julian, uniformity, having a uniform treatment of all the paradoxes, including the revenge paradoxes, that matters to them just as it matters to us. I'm just going to say some sketchy things. If you want to know more details about the framework, just ask your in-house inferential deflationist and it's going to answer your questions. So the idea is that valid rules preserve commitment. Not all valid rules preserve evidence. Semantic rules don't preserve evidence. And intuitively, the idea is that suppose I had evidence for true lambda, and then I can apply true elimination. So I get lambda, which is not true lambda. If evidence is consistent, then I have evidence for true lambda and for not true lambda, and that's not possible. That's not really the argument. The argument proceeds in a dilemmatic way. It makes use of sophisticated principles. It's non-trivial how to regiment this argument. It's not trivial to understand if it preserves evidence. Maybe I'm going to say something about it later. But that's roughly the idea. If evidence is consistent, the semantic rules cannot preserve evidence. If they don't preserve evidence, we cannot use them unrestrictedly within subproofs. Otherwise, when we close these subproofs and we apply classical introduction rules, we're going to end up asserting things for which we don't have evidence. Think of lambda. Lambda, if you assert lambda, you're going to assert many things for which you don't have evidence. Right. So, and yeah, I had this slide. Why? Because if you try to construct a paradox and you're not allowed to reason semantically under assumptions, to apply elimination rules for semantic predicates under assumptions, the situation you are in is pretty much this one. There's very little room for maneuver. So you have to try to fight your way out as a revenger if you can, and that's not easy. So yeah, if you worry that these restrictions are too drastic, for as far as validity is concerned, they are not, because they have a clever way to recapture uses of semantic predicates under assumptions when they don't create trouble. So the ones that don't involve paradoxical sentences. It's very nice. So yeah, and there's some technical results, and there's very, very nice things to say about this theory. I mean, it's quite impressive. So right, revenge for them. So we're not getting to the interesting. We haven't gotten to the interesting part of the talk yet. Can we run a revenge-like argument like the ones we saw before against Luca and Julian? Yes, we can. The relevant, I'm going to have to skip some details here. The relevant classical recapturing principle is just the T-scheme. The sentence satisfies the T-scheme if and only if it satisfies all the principles of classical logic. So the rules that Luca and Julian consider in the paper, in the book in progress, are that if you can derive absurdity from the T-scheme, apply to phi, then phi is paradoxical. And then you have the elimination, the corresponding elimination rule. If you have that phi is paradoxical and that phi satisfies the T-scheme, you get absurdity. Because paradoxical just means if it satisfies the T-scheme, then absurdity. And then we have these principles that are valid in the framework. So by conditional introduction, just from those conditionals, because we have to be careful with subproofs. So that's also the brutal way. And then you have a form of contraction that's really a weak form of error introduction. If you have phi yields, if phi them psi, you can infer the conditional directly. The details here are not very important. So we make use of the same sentence, revenge-like sentence, Rho. Then we prove that if Rho satisfies the T-scheme, then it's true, and you have it in blue here at the end. We don't need to go through the details. I think that's it's just a logic exercise. And then if you have that, if you have that, you can prove that Rho is paradoxical. And that's the key thing. So that's when you have a subproof for introducing the relevant semantic predicates. So you have a subproof for per intro, and you need to use parelim within that subproof. That's key. So that's, of course, that's going to be illegal for Luca and Julian because it's a semantic rule, and semantic rules fail to preserve evidence. And then if we can assert that Rho is paradoxical, we can assert that it satisfies the T-scheme. And if we can assert these two things and we have parelim, then we have absurdity. So that's just a logic exercise. There's nothing deep here yet. And of course, the reaction that they consider in the draft I saw is, our approach to the paradox is perfectly uniform. What we say about the liar, that the step of truth elimination in the subproof for negation introduction doesn't preserve evidence, applies also here. The semantic rule parelim doesn't preserve evidence either. These were in part where actually the correspondence started earlier, but that's been going on for a long time. So one of the episodes I'm going to tell you about briefly was me and Lorenzo saying, come on, we can't see how this can fail to preserve evidence. If you have evidence for incompatible premises, surely you have evidence for absurdity as well. And right, so if the premises really are incompatible, you also have evidence for absurdity. Lorenzo and I saw this just as negation elimination. If you have evidence for the premises of negation elimination, you also have evidence for absurdity. So either both rules preserve evidence or neither does. That's at least that's what Lorenzo and I were thinking. You might think, if you want to spell this out a bit more, you might say, well, it's impossible to have evidence for the premises of parelimination because they're incompatible, they're jointly inconsistent, and we're assuming that evidence is consistent. So for theory, it's impossible to have evidence for the premises of the rule and not to have evidence for the conclusion. So it's impossible that there is a counterexample to the claim that the rule preserves evidence. That's how we were reasoning. Not sure I fully understand this, and that's the way I reconstruct this step of the dialectic, but I'm willing to concede it. So the idea here is that there's two kinds of inconsistency. There's evidential inconsistency and inconsistency concerning commitments. And here the commitments are inconsistent when you accept the premises of parelimination, but they are not evidentially inconsistent. They would be evidentially inconsistent, that's how I understand the point, if parelim preserved evidence, but that's precisely the point of the issue. So that, I don't know, Julian will say if that's a faithful or unfaithful representation of the point. Actually, Luca has more things to say, but there's a clever response here to give, and I trust that the response works. The dialectic has been moving very fast, so so that's certainly a point for discussion. Then, before we get to the end, the dialectic moved on a character called St. Thomas, who only believes something if they can touch it with the hands, asking, can you justify the claim that the semantic instances, or the paradoxical instances of semantic rules fail to preserve evidence? So can you justify the claim that we can have evidence for lambda is true, but yet we fail to have evidence for lambda? And that's still going on. I think finally they were able to produce an argument that makes use of a certain closure principles. I have it written somewhere, so maybe if you're interested, we can look at it later. It's handwritten somewhere. And then the question arises whether the disclosure principle preserves evidence. And in order for this to be the case, the assumption that the premises, we have evidence for the premises of disclosure principles, but not for the conclusion, must be evidentially inconsistent. And what we say here needs to tie in what we say about par elimination. So that's just to give you an idea of how complex this dialectic has been, and there's been a lot more beyond this. That's not the place to talk about this in any depth. And I think the jury is still out. At least I still need to understand some of the moving parts. One thing I think I skipped over, this argument, yeah, it's the first bullet point here. I mean, this argument that they give for the claim that the paradoxical instances of semantic pools fail to preserve evidence depends on the assumption that if phi is a paradoxical sentences, either you've got evidence for its truth or you've got evidence for its untruth. So one might question this. One might question the claim that disclosure principle that they make use of preserves evidence. That's but so this is partly where the discussion ended, but it hasn't ended yet. And then finally, right, but it's a complex dialectic, and the revenger might get impatient and might say, we're never going to see the end of it. So let's try the atomic option, and let's try to push the curry button. And so I end this talk by putting a thought I really had between yesterday when I was at the dentist with the children and this morning. And I sent some rambling thoughts to Luca and Julian, who have been extremely patient. So I actually don't know if this works or not. So, and then for me, that's the interesting part of the talk. So let gamma be the following curry sentence. If gamma is true, then gamma is not supported by the evidence. So to construct this sentence, we're going to interpret evidence as a predicate. So so if gamma is true, then it's not supported by the evidence. I mean, it might be that there's a trivial mistake here, because this is rather untested stuff. So it's unwise to test it in a talk, but this is work in progress. So looking for feedback. And if I've made an elementary mistake, then so be it. I'm happy. We learn by mistakes, even, yeah, whatever. So now we run Curry's paradox using gamma. And we know how to do this. We assume that gamma is true. We get gamma, but gamma is the sentence. If it's true, then gamma lacks evidence. So we assume gamma is true again. We get that gamma lacks evidence from the assumption that it's true taken twice. We apply error introduction. So we show that on no assumption that if gamma is true, then it lacks evidence, but that's gamma. Truth introduction, gamma is true. And then we conclude that it lacks evidence via modus ponens. Well, maybe that's true. So is this a paradox? That's the first, that's a possible choice point. It might be true that gamma is not supported by the evidence, but I don't think we should be able to prove this using Curry's paradox. It's a bad argument. So I think we should invalidate this argument. At least my objection, the move that I'm considering here works if we try to invalidate this argument and justify our claim that it's invalid. So let's assume that we want to block this instance of the paradox. And if we are Luca and Julian, I mean, on the approach that we are considering, in order to do that, we need to claim that the step of truth elimination in the subproof, the very first step, remember, we assume that gamma is true, we got gamma, that step doesn't preserve evidence. So it must be disallowed. So we must assert that we have evidence for the premise of this step, and then we don't have evidence for its conclusion. I mean, maybe we want to assert that there's a possible situation in which we have evidence for the premise and we don't have evidence for the conclusion. I don't think it matters much, because then if we do all my reasoning within a diamond, then we produce triviality within the diamond, and we show that absurdity is possible, and that's not true. So I don't think that this matters. So I'm going to stick to actuality. So I'm going to say maybe that's wrong, but I'm very uncertain about most of the things I'm saying. But we want to assert that the relevant step of truth elimination fails to preserve evidence. So we have evidence for gamma is true, and we don't have evidence for the conclusion of the step of truth elimination. We don't have evidence for gamma. Right. So we assert, it follows that we assert that we don't have evidence for gamma, so gamma lacks evidence. And via via conditional introduction with vacuous discharge of true gamma, sorry, there's a quote missing there and another one here, we get that if gamma is true, then it lacks evidence, which is gamma. So our assertion that the relevant step of truth elimination doesn't preserve evidence implies gamma, it seems to me. But if introduction is evidence preserving, and it is, then we have evidence that we don't have evidence for gamma. That's part of our own view. So we have evidence for our own view. So we have evidence for the first thing there in red, for the claim that we don't have evidence for gamma. But this claim entails gamma evidence. It entails gamma by means of evidence preserving principle. So we also have evidence for gamma. So we have evidence for gamma and we don't have evidence for gamma. So this seems to be a problem. So that was the dentist thought that I had yesterday, and seems to be an appropriate way to close the talk. There's a last slide. Yeah, perhaps we only assert that it's possible that we have evidence for the premise of the step of truth elimination and not for its conclusion. But I mean, there's two things one can say here. And the third thing that's wrong that I told Julian and Luca, but I'm not going to repeat it here. So one thing is that the evidential status of paradoxical sentences doesn't change across model space. These are always the same. So if there's a possible world in which we lack evidence for gamma, then we also lack evidence for gamma in actuality, one might think. And then the other thing is that let W be the world in which gamma is not supported by the evidence. The people who live in W are going to assert that, I mean, if you run the paradox, I mean, yeah, they're going to assert that gamma, we don't have evidence for gamma, and it would seem that we can run the paradox there, maybe. Okay, so that is my last slide. Thank you for your patience, and yeah, I look forward to your questions. Thanks.